Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. The pKa of a carboxylic acid is influenced by inductive field effects of nearby electron withdrawing groups, EWG. EWGs stabilize the conjugate base, carboxylate, by dispersing negative charge, increasing acidity, lowering pKa. The closer and stronger the EWG, the greater the acidifying effect. A CH3CO2H is equal to acetic acid. A simple carboxylic acid with a weakly electron-donating methyl group. Its known pKa is 4.76, but in this set the closest value is 4.80 s. The methyl group slightly destabilizes the carboxylate relative to formic acid, giving a pKa around 4.76 to 4.80. B CH3, 3N plus CH2CO2H is equal to betaine trimethylammonioacetic acid. The positively charged quaternary ammonium group is directly on the alpha carbon, 1 carbon away from Co. This strong EWG exerts a very large inductive effect, making this a very strong carboxylic acid. The pKa is drastically lowered. The closest value is 1.83 R. This matches because the plus N is directly adjacent, alpha position, giving maximum inductive withdrawal. C CH3, 3N plus dash CH2, 4 CO2H is equal to 5 trimethylammonio pentanoic acid. The positively charged nitrogen is now 4 carbons away from the Co group. The inductive effect diminishes with distance, so the acid is stronger than acetic acid but weaker than betaine. The pKa is 4.27 Q. The plus N is far enough that its effect is attenuated but still measurable. D O2C CH2CO2H is equal to hydrogen malonate malonic acid monoanion, second dissociation of malonic acid, or the acid form of the monoanion. The O2C group is a carboxylate anion, negatively charged, on the other end. Despite being negatively charged, which would normally destabilize removal of another proton, the carbonyl carbon still exerts an inductive EW effect, but the negative charge also has a repulsive destabilizing effect on ionization. However, in the context of this problem, O2C CH2CO2H represents the second pKa of malonic acid. The first pKa of malonic acid is tilde 2.83 and the second is tilde 5.69. So this represents the second ionization of malonic acid where 1 carboxyl is already deprotonated, giving pKa is equal to 5.69 p. The already present negative charge makes it harder to remove another proton, raising the pKa. Why other options fail? Betaine, B, cannot be 4.27 or 4.80 because direct alpha position plus N drastically lowers pKa to tilde 1.83. The malonate monoanion, D, cannot be 1.83 because the negative charge on the adjacent carboxylate raises pKa rather than lowering it. Acetic acid, A, cannot be 1.83 or 4.27 because it has no strong EWG. Summary of matches. A. CH3CO2H pKa 4.80 s. B. CH3, 3N plus CH2CO2H pKa 1.83 r. C. CH3, 3N plus CH2, 4CO2H pKa 4.27 q. D. O2C CH2CO2H pKa 5.69 p. Therefore, the correct answer is AS, BR, CQ, DP. Therefore, the correct matching is A matches S, B matches R, C matches Q, D matches P.